Hi, in this video we are going to look at differential amplifiers. So basically we know an amplifier will take a signal and amplify to give an output. Okay, so the signal could come from a microphone, a sensor, or other things. But then comes the effect of noise. For the single stage amplifier, if the signal is corrupted with noise, then both the signal and the noise are amplified. So we get an output of amplified signal together with amplified noise. So the differential amplifier usually takes a differential input all the times and can take or give out a single-ended output or a differential output. Okay, what do we mean by a single-ended output? So just like op-amps, we are used to having two inputs. So that should tell us almost every op-amp has a differential pair in the input side or the input stage. And the output could be a single-ended output, which is a voltage measured with respect to ground. Okay. Sometimes a differential pair could feed into a differential input. So I take a differential input and feed it into another differential input. But sometimes one stage, the first stage of the circuit, could take a differential input but the following stage could allow only a single-ended input. In that case, we want to find ways of converting the differential input into a single stage output to feed the following stage. So what is most crucial about the differential input? Assuming there is a signal and noise, then feeding this signal, the differential input and the differential pair works in such a way that it can reject anything common to the signal. So it rejects common. So the commons could be noise. So a typical example, assuming I have my microphone. Okay. So assuming I connected the microphone to a single staged input, like the common emitter stage amplifier. With all biasing conditions taken into account. There could be noise in the VCC. There could also be noise in the microphone signal itself. Now the noise in the VCC could corrupt the output voltage. And the noise in the microphone signal, the small changes in voltage, could also affect the output if there are small changes in the current as a result of the small changes in the voltage are also corrupted by noise. So that tells us how we sometimes hear a lot of humming sound from speakers. The microphone I'm using to do the recording is not so good when it comes to noise cancellation. So you could hear a lot of background noise. So that is when differential pairs come in. There are other applications as well. I've also spoken about op-amps taking two inputs. So at the input stage of the op-amp, there should be a differential pair. Sensors also take signals, and the signals could be very small, 2 millivolts or even less, which are easily corrupted by noise. So in the next video, we will see how differential pairs help us in cancelling noise and giving us better stages. Okay, until then, goodbye.